Hi, my name is Thomas Kim. In this session, we will learn how to use multiple semantic data types in syntax parser using Bison. Also, we will address shift reduce complex. Also, we will talk about operator precedence. We will talk these things in this video. This video continues from my previous video. Please download the source code. Click this link in this YouTube. Also, to follow with me, you have to watch my previous videos in this series, how to implement go-to and functions in scripting language. You especially have to follow in sequential order in this list here. Okay, let's get started. If you downloaded your sample source code, you will have to unzip it. Then if you unzip it, then select copy and paste it to your working folder. Then open it in Visual Studio. When solution is loaded successfully on your Visual Studio, right in Solution Explorer, right-click Code Editor, set as Startup Project, then press Ctrl F5. It should build successfully like this. If you have problem in building my solution, then you probably have to watch my previous videos about setting Bison and Plex and scripting language development environment, about how to install Bison and Plex, etc. from in my previous videos. Now, in Select Solution Explorer, we will make a few corrections in our previous solution. Click lib parser in Solution Explorer. Then Bison and Plex files. Double click Lexa L parser Y. I will make a few changes here. No, before I make changes, in class view, parser, talk playpen, here Paso Manager. Then here, copy these to text and paste. I will make it full. Then is result empty. I will change like this. Full is error empty. Is error message empty. Change like this. Then copy. In C Paso Manager, double click it here. Put it here. Then remove, fix like this. Then copy again. Here, double click it here. We will put it here like this. Then remove. Return this and result empty. Okay, here again, return this error message empty. Now save all, close all. In code editor view, here Control F, we are going to find get result count like this. In select current project. Next, here we will change it to like this. Is the result empty? Like this. Okay, so we will copy this text and also here like this. Then here like this is error message empty. Then copy once again, then paste like this. Okay, save, then copy this and put it here. Here, change it to build, save it, and we will make one more changes, not here, not in this project. Here, console application, global. We can also change this. Is result empty? No, we can just remove this. Here is the result empty. If not empty, it means if not empty. Then here again, and we can remove it. It should be if not is error message empty. Save. Now build in Solution Explorer. Right click solution, build a solution. Sorry, I made error. EMPTY. Now build again. Control F5. It should run as before. Okay. Okay, it runs successfully. Now close it. This we fixed a few things. Now in lexical parser here, double click parser Y, lexer L. In parser Y, in our previous video, in our previous session, we used only single semantic type, lone semantic type double. Now we want to introduce int integer data type simultaneously with the double. So to prepare, we can use this code again for type integer. So I will change some names here. dble, I will append dble, expl dble. Then also we have to change here dble, okay, save, Control F7. Clear, Control F7. 121, it should be dble, save, Control F7 again. Okay, it builds successfully. If we run it by Control F5, it should run as before. Okay, it should run as before. Okay, now close it. Now we introduce semantic data type int. I will tag it intz like this. Then copy here. I will copy it and change it intz. Tag it. Then literal intz. Then we have to change literal int. Okay. Here again we copy. These are non-terminal intz and intz. And scroll down. Now we will copy from here. Copy and paste. From here we will change dble to intz like this. I am trying to show you that this method doesn't work, or it's very hard to make it work. So we will introduce operator precedence very soon, in a few minutes later. And it should be literal int, don't forget it. Save it. Now double check if everything is fine. Now here we need to add one more. Copy, paste, and make it intz. Okay, so it should be double. Now save them all and let's run. Control F5. No, before before, let's test it with Control F7. Let's build it. So since everything successfully built, compiled, Control F7, this Paso successfully built. Then now let's Control F5 to build and run the whole solution. Now we tested 1 plus 3 times 5. It should work. 3.5 5.6 it should work, but it does not work. 5 the last line, this line, fifth line, this line will not work. Let's run it. I will explain why. Wow, it worked. Sorry. We save it. Then I forgot to make one more things here in lexical scanner. Now copy the whole text here as seen. Copy, then paste like this, and integer should come first. Okay, integer should come first here. Integer is defined like this. Integer. Okay, integer is defined here. I classified it long ago, of course. Paste it here. Please note that you have to put integer should come first, then real. I will explain that in future videos, not here. Then we have to change it to intz, and this should be WTOI, and this should be intz. Save. Now Control F5, build and run. Now load our sample. This should not work. See, syntax error. First line, this line works. Second line, third line works, but fifth line it gives syntax error. The reason because this is integer. Line 9.1 is all about integer operation, integer arithmetic. And line 3 is floating point, double expression. But line 5, this is integer, this is double. So it doesn't work currently. We have to change it. We have to fix it. Close this. Then in Paso again, we will try to fix it. Then here, let's try put it here. dbl, copy this text, then paste. Instead of term dbl, make it term intz. Okay, term intz. Save it. Then Control F7 to build. Control F7. So Paso is generated. Paso CPP is generated without warning or error message. Now let's run. Now load it. So this will not work. 5.6. This line will work correctly. Let's try it. Let's run it. Okay, it runs correctly. But if we change order like this, we changed order, and it will not work. This line will not work. See, syntax error. This works, but this doesn't, because this is integer, this is double, this is double integer. If we compare it with our grammar, this is double term integer, double integer works, but there is no integer double. Okay, so we are tempted to make like this. Then we can try it like this, and we will say term and expr dble. We may try this because this is double integer double. Now let's compile it. Control F7. Voila, we have a warning 3 shift reduce conflict. It doesn't work actually. If we do this, the program doesn't work as we expected. When you develop scripting language, you should prevent all kind of shift reduce conflict or reduce conflict. You have to be very keen, very cautious about shift reduce conflict and reduce conflict. This warning is very important, so it doesn't work. And whatever you do, it's very hard to manage. We are currently using 2 integers in 2 data type, 2 semantic data type. When we develop a language, we may need lots of different data type. Then this code will become very big. Semantic Lex parser grammar file can be very big in this way, so we cannot. This approach doesn't work. Instead, we will introduce operator precedence, and we will change this significantly. Now let's go. So here I will first disable this. I will disable all integer type, and also I will disable it. I will leave only double here. I will disable it, and I will just delete all. I will start from here. Now making expr I will copy this and plus minus times, then divide unary operator, and parentheses. Here plus, this should be minus, this should be times, divide, and this should be 2 minus 2, and this should be just 2. Save. Now fix like this. Okay, so I disabled the integer type here. I also disabled the integer literal, only left double. I disabled the integer, and here we don't need these things. We can just remove these. Okay, save. Now let's compile. Control F5, Control F7. Double symbol, so I have to change it. DVLE. Copy. Here. Like this. And save. And Control F7 again. EXPR DVLE 115 EXPR DVLE. Okay, so I made a mistake here. I made a syntax error here. LIT DVLE. Okay, if we add it, it should compile. Now we have different error message. DVLE. Control F7 again. Okay, it built successfully, but it's not. We have 20 shift reduce conflict. We have to remove all shift reduce conflict. To remove that, the primary reason it has such many plus, minus, plus. These conflict, and I will talk more about shift reduce conflict in future video, but I will resolve this problem first here. Before start symbol, left means left association. This is association, and say percent left is keyword. It is used to define operator precedence. Left means left association. Also about left association I will talk in future videos. Left say this plus and minus are declared in the same line with the keyword left. It means they are of same precedence, and then comes a star, asterisk, and slash. They are of same precedence, but this is down, this is up. This has lower precedence, and it has greater precedence. As you goes down below, it has a higher precedence. It has higher precedence. It has lower precedence. Okay, not president. Then let's build again. Control F7. Wow, shift reduce gone. Okay, all shift reduce gone. Now if we run it, it will run, but I will enable now int like this, and also return, also expr save. Now I will copy this part, copy and paste. Now change it to int. It should be int. Okay, control save all. Now control F7 again. Here I forgot, we have to put it copy, paste, then INTZ. Save. Control F7. Now it builds successfully. Parser Y is generated successfully without any warning. Now Control F5 to build and run the solution. If we wrote and we run, it still doesn't work. So we will address this problem. For temporarily, we will introduce here. I will arrange it like this for easier read. Here I will introduce like this. Copy and paste here. Say INTG double. I will copy once again. Please note that it should be in double EXPL DBLE section grouping, and it should be DBLE, and it is INTZ. Save it. Control F7 for compile. So it builds without syntax error, or shift reduce conflict. Now we run Control F5. Now we run. Voila! It works. It works perfectly. So, but what about we defined in addition only? So we introduce another here, EXPR DBNT, okay. See, we make another rule here, DBNT is semantic type is double. Here we copy this text, cut, then paste. I will paste several times. Then I will arrange like this. Here it should be minus and minus, then plus asterisk, then slash, and make sure we also have to change this minus times slash, okay. Then don't forget semicolon here. So I will make it bigger, okay. Please understand, read this text. Integer double integer, double integer, double integer, all combination, okay. Save it. Now let's run. Control F5. No, before we do that, Control F7. We made a mistake here. Here now we append here. We can put it here too. EXPR DBNT. Okay, then like this. Okay, save. Don't forget fixing like this. I will make it smaller that you can see the whole changes. Now build Control F7. It builds without error, without shift reduce conflict. So it successfully builds. Then let's run Control F5. Now it builds correctly arbitrarily, and we can do more computation. We can intermix more computation. For example, we will do multiplication, subtraction. We can mix arbitrarily like this. Save, run. See, it works. Everything works. We can now intermix integer and float arbitrarily. And if we build cancel application, build on cancel application should also work. Okay, so this concludes this video. It concludes this video. Say this is multiple semantic data type 1. 1 means there is another part 2. This is part 1, part 2. Part 2 is very important. Okay, but please note that the problem of this approach is that if you have watched my previous video, you understand that it reserves result. It saves the computation result in the class here. In this result data member is the queue, is container, double container. But what if we should be able to tell the result of computation if it is integer or it is double or it is a string or this is float, this is whether it is boolean value. We have to be able to differentiate this computation result. So this approach, today's session will be basis for our next video. Thank you. Please subscribe and thank you for watching. I will put the link for download source code download link in the description section below. Thank you for watching.